Okay, I hope now you are confident to how to estimate heritability from a full SIP design. So we can go next. So in this case, the question is simple. So you get the phenotypic correlation around 0.166. Then if the pair is MZ twin, then what is heritability? And similarly, if the pair is full SIP, what is heritability? That is what you did here, right? And if the pair is half SIP, then what is heritability? Can you work out? So your phenotypic correlation is fixed, as we assume. Then previously we used full SIP or BZ twins, right? Then that divided by sample correlation as 0.5. Then this give heritability as 0.333, right? And now, what if the design was MZ twins? Then you scaled by 1 instead of 0.5. Then what would you guess? Would the estimatability is increased or decreased? Let's have a look. So now heritability is decreased, right? Then what if this is half SIP? Then when half SIP, then the sample correlation is now decreased at 0.5. Then heritability goes up. That's 0.66. Okay. So design is important, and the estimate heritability is depending on sample correlation, right? So if given phenotypic correlation, the same value for the phenotypic correlation, then if you use design as a lower sample correlation, then you get the higher heritability. Did that make sense? So we go next. Yeah, then so with the same code, except now heritability goes to 0.8 and run it. Okay, so we can run. So we use the source code, code names. Okay, so we simulate through heritability as 0.8, and we used full SIPs, and now phenotypic correlation is increased from the previous, right? That would be expected because when you use high heritability, then the phenotypic correlation can be increased. That is a function of heritability as well as sample correlation, right? Then now the heritability, estimate heritability is 0.76. So this is a confidence interval, and it includes the true uh, heritability, right? So estimation is pretty accurate, but it's just covered by confidence interval. But if you can increase the this number of record, number of SIPs, then probably this confidence interval is reduced and you get more accurate estimations. Maybe we can try, or you can try by yourself. So as same as before, also you can work out what is the using design as MZ or full SIP. That's what you did here. And what if the design is based on half SIP? Then you can get the different number of heritability, right? Okay, then now get back to the point 3 as before. Then goes to next questions. Yeah, so this is same question as before, right? So now sample correlation change 0.25. So 0.25 is 0.25 is for the half zip. Then we already have done that, right? Then uh, probably you can do by yourself how they change. So you can get familiar with the design and what design used and how can you estimate and what is sample correlation and what is heritability, then how you get it. So you'll get hopefully you get make sense about this approach. Okay, then yeah, now this is about the power or in relation to the confidence interval. So in the code, let's go have a look. It's code, and what if when you change this number of record as 100? So at the moment, yeah, we let's try based on full SIP design. Let's try the number of record for the SIP as 100, then to see what happens. Okay, okay, can you see? So true heritability is 0.3, and we used full SIP design. Now phenotypic correlation is around 0.02, then divided by zero point 0.5 will give around 0.04. This is quite far from the true value, but the confidence interval is huge from minus zero point 0.3 to 0.4. This actually includes true value, but this is a huge interval. So the estimation, the precision is not that high, right? So that is expected because you used only 100 record. Now, what if you try with 10,000? Okay. Now, uh, the simulated value is the same. Then now the estimate heritability is quite close to true value, right? And confidence interval is very narrowed down, right, from 0.28 to 0.35, right? So it's very close to true value. Maybe you can try with more number. Let's try probably 100,000 million. Okay, then yeah, then it's very close to 0.3, right? Then confidence interval is only 0.001 or something. So this is really high, enough power that close to true values, right? So in design, it is important in terms of power. So that number of record is very important. Okay. So the next question. Yeah, so this is related to confidence interval. Probably, hopefully, you can do by yourself following this question. So you can repeat 10 times for A and 10 times for B, then work out what is the mean and variance of the estimation. So you can run each of this analysis 10 times, then you get the 10 sets, 10 different value for estimate heritability for this, right? And also when you do 100 record, also you get the value for this. Then you get the mean and also variance. That is a function of probably confidence interval. So uh, hopefully you can do the 10 replication then to see how they distributed. That should be interesting. Okay. Yeah, so from this exercise, So we can conclude that the sample size is one of the key factors to determine the accuracy of estimation. Okay.